It's someone getting on Zoom. Okay, let me see if I've got the right screen here. I think so. So if you guys have looked at the modular component development thing on the Google Docs, I did have a couple of people in the other class complete it using a non-OTC email account, and it did record it. I think that last one with TFS was just have people that were closing out of that Google Doc because they had their TFS all established and they didn't realize they needed to go ahead and click submit. So I think we're okay on that one. That assignment, that Google form, has you watch all sorts of videos. It can get long. You need to watch them. We don't have time in our seated class to go through all of that stuff step by step. It would take us forever, and it almost does in the videos. So use them at home, pause, go get something to eat, wake yourself back up, come back, do some more. You know, I've told students for years that I'm considering selling my videos for people who have a hard time falling asleep, whatever the case may be, you know, nighttime stuff. You know, you're supposed to listen to stuff like that while you're sleeping, and then it gets stuck in your brain, right? Best time to learn when you're sleeping. Have you tried that with those videos? You'll wake up in the morning saying weird things in my voice, and you won't know why. Because your brain got all stuck in there. So do that if you need to, but we're not going to go through those presentations in class, and we won't go through that whole series of getting our class files created because there are videos for that, but we're going to try to do a little bit of it so that we get some feeling for it in class. So you do need to watch them unless it's something you've done hundreds of times before and you feel very comfortable, and I doubt that that's the case. So in this presentation, I have a blatant transformer video. Actually, it did show up in the freely available non-copyrighted things. But why would I have a transformer here? I'm talking about object-oriented programming. Because to me, a transformer is like the ultimate in object orientation, right? It's all these different objects that become another object. So it has polymorphism, right? It can morph from one thing into another. It has inheritance implied because it can be, you know, one type of object and then it can turn itself into a car, inheriting all of the capabilities of a car. It encapsulates all of these things together, and we never have to worry about it. It's very abstract, right? How does this transformer change into a car? We don't have to worry about it. It's all been conceptualized and abstracted. The transformer knows how to do it. We don't have to. We can tell it to, but we don't have to know how to do it.
All the parts in here is already present. You don't need to tweak them.
Yeah, we got some stuff. So why transformers? Well, let's look at this data structure here. If I have a transformer, now we're not going to talk about what site I used for this research, because you know where I got it, from Wikipedia. But if I look at this and think, what about transformers? Okay, all of these things are transformers, right? They're all some type. But we have Autobots, and we have Decepticons, and we also have other Cybertronians, which I wasn't completely aware of until I was researching. Now, all of these types of transformers can inherit from our base transformer class. They're all transformers, right? And then we can have different types of Autobots too, like a Prime, like Optimus Prime. The Primes are special types of Autobots because they're the semis, so they can be a little bit different. And then the other Cybertronians, we also have some differences. We can have Dinobots and probably other types of Cybertronians that could inherit that other Cybertronian class type. So all transformers can do certain things. In general, they can all walk or mobilate, locate, can't say the word, locomote, that's the word. They can move somehow. They can usually drive, They all transform, and that's a really important point. They can attack and defend and roll, but all of the transformers that we look at have different implementations of these things, right? Because one type of transformer to drive might mean something very different to a different type of transformer to drive. The biggest one that we can see is the transform method. Every type of transformer would have a transform method, right? Every one of them can transform, but each type is going to have a different kind of transformation. So how do we handle that in our code? We need to do all these different transformations, but yet they're all really a transform. We're not doing anything special there. Let's think about our transformer base class here. In our base class, let's say we're going to need some things, some data items, like the name, the function. Did you know I didn't know this until I was doing my Wikipedia research last year. Did you know that every transformer is assigned a specific function? In the universe, they all have a job. And so they each have their own function, like to guard the whatever. Then they each have a title. You can look it up on Wikipedia. It's weird as can be. Now, some other things that we might want to keep track of in our base transformer class might be the number of weapons, type of weapons, I don't know, maybe weaknesses, maybe the state of the transformer. Is it currently transformed, or is it currently in its base state? There are lots of things like that for its state that we might need to keep some Boolean switches for. So if I look at Bumblebee here, I could say that here, this is his native state, and this is his transformed state, but we would have to define that. You know, is this his native state, and this is transformed state? That would be something that we would have to decide as we were designing our application. Okay, so we have 4 basic tenets of object-oriented programming. The first one that we're going to talk about is abstraction. These are abstract paintings, and I want visuals here for you to be thinking about it so that when you see this word on a certification test, you're like, what was abstraction? Oh yeah, abstract is where I can't quite see the details, right? I can tell that I'm like a city or something, but I can't quite see the details. So with abstraction, we're making the essential features available, but hiding the non-essential complexity. So a transformer can use its transform method to turn into its alternate shape, but the mechanics of that actual transformation are hidden. We don't have to worry about it. We can just say, hey, transformer, transform, and it will do it, right? But we don't have to know how. So that's abstraction. The difficulty, the details are hidden. It's a little abstract from our point of view. Now, another way for us to think about abstraction is actually at the class level. We can mark a class as abstract, and that means this class exists, it's valid, it's called a transformer class, but we actually can't use this class to make an instance. It's too abstract. It's missing some details, and we'll see why. Now, looking at our transformer class here, here's our private data elements, some public properties maybe, and then down here we have a special kind of method where we've declared an abstract method, and it's our transform method. When we just declare a method this way in a base class, notice an abstract method has no method body. There's no curly braces. It just ends right here after the parameter list. That means that we can't implement this method at this point. We don't have all of the details. We don't know how. But every class that inherits from this class must implement that method, that transform method. So if it's an abstract method in our base class, all of the classes that inherit from our base class must implement the method is an override. Now, the other type of method that's here on this display is a virtual method. Now, a virtual method is actually going to have a method body. It's got some code, it has some things to do, but because it's marked virtual, we will allow this method to be overridden. Okay? It does not have to be, but it can be. So the virtual keyword says, I can be overridden. If I don't have the virtual keyword, I can't be overridden. And then the last one is the toString, which shows us an actual override, because that toString method in the system object is marked virtual, so we can override it. So all of this is abstraction. An abstract class cannot be instantiated. We have a high-level template of the class. We can allow overriding. A virtual method can be overridden. Abstract methods must be implemented by derived classes.
Is virtual kind of like having a default in a case statement?
Yeah, it really is, because you're basically putting the default code
So
in your base class.
You probably put like a print line thing. This was like in case you want to not have it crash at times.
Right. You could put something in there. Or you might have like, you know, the default favorite color is purple, and we just put that in. And then if this other class wants to override that, they can implement that. Yeah, yeah. Perfect. So that's abstraction. We're keeping the details kind of fuzzy. Now, what about encapsulation? I like these encapsulation pictures. First of all, this picture is some sort of like work anniversary award. It's like one of those crystal blocks. And inside the crystal block, it has some brass and some dirt and some stuff. And I don't care about that. But I wanted to show you that stuff is encapsulated within that crystal, right? It's trapped inside there. It's not going to come out. It's encapsulated. So that's one instance of encapsulation. Right here, this is a picture of a piece of paper, and it's got those laminating sheets. You know how those things stick to both sides? That piece of paper is now encapsulated inside those laminating sheets, right? It's not going to ever come out. And then the last one, this one is good because a phone shows you both encapsulation and abstraction. So here's my phone, or a phone. It's a Samsung, so you know it's not mine. But here's this phone. Here's the back of the phone, like the metal layer, some circuitry, some more circuitry, and finally the screen. So when we put all those things together, all of the inner layers are encapsulated within the phone, within the back and the front. And the phone is implementing abstraction because you can use that front of the phone to issue commands, and you don't have to worry about how those things are actually being processed. We don't have to worry about how all those physical circuit connections are being made inside that phone. It's abstract to us because of the encapsulation. So when we look at a class, all of our private class fields, this is the class, this blue circle. So everything inside this blue circle is encapsulated by this class. Our private class fields are inside the class. There's no exposure. There's no way to get to those from outside of our class. But if you look at our public properties, our getters and setters that are associated with those class fields, we allow external resources to get and set those values through our properties. So our private class fields are exposed through our public properties. But they're all encapsulated and kept safe. We don't allow public exposure unless we want to. Now on the bottom half of the circle, we have methods. So first of all, we can have public methods within our class. These public methods are processes and actions that can be performed externally. So something outside of our class could execute those methods. But we could also have private methods. And we can have private methods with actions that are hidden. So all four of these types of things are encapsulated within our class. So if I saw a test question that said, exposing private data elements through public properties is an example of, we would not say inheritance, because that has nothing to do with it. We would say encapsulation, because I've got them all hidden inside there. Okay? So that's what we're looking for. So encapsulation. It's a package where we can keep the data attributes and behaviors combined as a single unit. We're going to hide the implementation details. Remember last time I was talking about my friend Econoco, who wrote that code to figure out how much a storage tank could hold. She had all of those details hidden from other people. They could use that code, but they didn't have to understand what was going on there. Now, in our example of our transformer, each transformer has states and attributes like the color, their type of weapon, what kind of movements they have. And each transformer has behaviors like transform and roll and attack. So all of the details of how the attributes and behaviors interact are hidden or encapsulated in the appropriate class. One thing that I was thinking about when I was doing this that I didn't really follow through on, you know how that happens sometimes even when you're coding, is when we're looking at, where did I have it? It's way back here, sorry. Weaknesses, and I didn't put it in the presentation, but I wanted you to really think about it. Weaknesses are something about this given transformer that we would want to keep track of, but we wouldn't want to make that a public property, right? Because we don't necessarily want others to be able to get information about our weaknesses. So that's just one thing where you could think, well, we could keep track of that in our transformer class, but not have a property that allows others to see it, because that's the kind of thing we want to keep hidden to ourselves. Okay, inheritance. We already did inheritance last time with the petals around the rose thing. You guys saw how easily you could take advantage of the system picture box object by using it as a base class and inheriting from it. So when we were doing inheritance, we noticed that we got all of the capabilities of the picture box, plus we were able to add additional things to it. So I want to look at some of these and think about if they're related. Let's look at the Bouviers, because this is just such a great picture. So this is Jackie, Marge's mom, and Patty and Selma's mom too. And they want us to think about what kinds of characteristics they have that might be inherited. Marge's hair is really tall and kind of a little curvy, and so is Jackie's. Do you think that's inherited? Is that an inherited trait? They say that it's possibly inherited, but we need more information to be sure, because it could just be that they go to the same hairstylist, right? So we don't know for sure, but it could be. What about their bad posture? And they say that's something that probably is inherited because it's more along the lines.
Well, Jackie's comes with age.
Yeah. Yeah, Patty and Selma have the same posture from all their smoking. I don't know. But they say, you know, some of it's inherited, some of it's not. Now, when we're doing inheritance in our program, it's really easy. We get it all. So we don't have to worry about which capabilities and attributes we inherited and which ones we didn't. We get them all. The morning class thought this picture was funny too. I said, this is a family tree picture. So they have grandparents that had a redhead and a blonde. So the first generation was 2 redheads, 2 gingers. And then this ginger married a ginger and had 2 gingers. This ginger married somebody that had black hair and had somebody that has black hair. Their point being that a trait like that can be passed on to the next generation, but is not always passed on to the next generation. So again, in our inheritance, we don't have those kinds of or conditions. If it's in the parent class, we're going to be able to get to it as long as it's not marked private. So our transformers. Whenever we're looking at this, that transformer class could be called the superclass, the parent class, the base class. I bet we could keep going. We could probably find about 20 more terms that people use to describe that parent class, and they're all right. So remember, when somebody talks down to you and it's like, you mean the base class? Do not let them take away your confidence, because they're just doing that to try to boost their own ego. And the truth is there's a whole bunch of terms that mean the same thing. So you are not wrong. neither were they. But the transformer is our base, our parent. Now, when we look at our first level classes that are inheriting from that, they're going to be the derived class or the child class. We could probably, again, find even more. And then we have a Dinobot down here to show that that inheritance can keep going. It doesn't have to stop just at one layer. We could have many, many layers of inheritance. Yes, we could have great-grandchildren. And they would see everything all the way up to that first parent. So inheritance. If we look at our transformer class as a parent to this Autobot class, first of all, we know that in C#, this colon indicates there's an inheritance happening. We have our private data values, and we have our public properties that I'm not showing. And then we have a weird constructor. When we do constructors for a derived class, we have to specify all of the parameters for the derived class and the parent class. And then we have an extension where we put colon base and specify all of the parameters that get passed to the parent. So we'll try to do that today because that's something we really need to get a little bit clearer on. Now, in our Autobot class, we're going to override the toString and add on more than what the base class had. We're going to override the attack method because this Autobot is going to do a special type of attack, and we're going to actually implement that transform method that we have to implement. And it's going to say things like, turn the tires in and stuff like that since we're an Autobot. When we look at our class statement, the first thing should be our access level. This class statement doesn't have an access level. So is it going to be public or private or protected or what? What's our default?
Abstract, right?
Do what?
Shouldn't that be, hang on, I have it up down here.
What's our default?
Public abstract class?
It should be public, but it's not. So is it going to be public? What's the default? What's it going to end up being?
Private level, right?
Private. Yes. So we could have trouble with this class because it should have that public keyword on it. Now, after the colon, we have the name of the class we're inheriting from, and then we have a special constructor where we have parameters for both classes separated from the parameters for our base class. Our virtual methods can be overridden if we want to, and our abstract methods must be implemented. So inheritance. Inheritance is what really allows for us to reuse our code. Our transformer class, we seek, it can be extended to create all these different types of transformers. Just think if we had to reinvent that code every single time. Even if it's a small class, we're getting a lot of advantage by not having to reinvent it. Now, we might create a new type of transformer, a child class that has different characteristics. We have that ability. So a derived class contains all of the data and methods of the parent, plus their own data and methods. So let's see if we were looking at our picture box class last week. We saw it had all of these data and methods associated with it, like the image name and the position on the screen and all those kinds of things. Well, we inherited from that, and we added a couple more things, like our score, whatever. And we call that a die D6. So the die D6 ended up being all of this stuff all together. So it took the parent information, attached the child information to come up with this new chunk of information that's available to that class. That's from polymorphism. I like the monarchs. You guys seen any monarchs? You know, monarchs are on our endangered species list now. These and everything.
I think that's partially my fault.
Did you kill a
When I
bird?
was a cop.
Huh?
When I was a kid, we'd go out to the wildlife sanctuary and catch them.
Butterfly
Well-
effect. You caught one of them and now they're going extinct.
Yep, that's what it is. Like Jay didn't like us, we didn't die. I think it has more to do with like Monsanto than you. Just guessing there. I think Monsanto is our culprit there. And like at my yard, I'm really worried because like I have some in the back, but on the side where the road is really close, I don't. So I'm concerned that there's,
Don't get me started on Monsanto.
yeah, I'm worried about it. You know, my daughter was doing research, I don't know why, and sometimes I don't ask questions why. She's a librarian, sometimes she just researches for no apparent reason. And my husband's uncle he has a dairy farm in southeast Missouri. And Heather told me, I had no idea, he's the 3rd largest land owner in the state because of his dairy farm out there. And he has like, she said right now he has like 27 active lawsuits against him from Monsanto.
Yep.
So he's getting hit hard because he owns all this property, I guess. But she said Monsanto wants all the border land property of the states. And he says he owns all the border to Arkansas. I guess they want it.
They've got thousands of lawsuits against them right now. I'll elaborate after class.
It's crazy. Didn't even know.
Are they the company that does genetically modified?
Yeah.
Yeah.
And they're saying you allow your
seed.
to absorb the stuff we threw into your property.
Your seed went on somebody else's property and we
Well,
own
the
that
birds
seed.
eat it and then they drop it in your property. Yeah, that's the problem with it.
A bird ate a hunk of corn
Mhm.
and it defecated in your yard. Now you're growing our stuff. We want that. We want our land.
Mhm.
Hey, bub, you're not controlling your stuff.
They're
You
gonna
should
own it
start
all.
selling them.
It's like copyright. If you, the reason why they have a lot of copyright laws the way they are is because if you're not controlling it, then you lose copyright. That's why it's like, well, maybe it should be the same thing with like crops. If you're not controlling where your crops land, it should be your fault, not someone
Yeah.
else's fault
I
because
agree with you.
they didn't steal your seed. You know, it's not. Yeah.
Well, it's a lot more than that. I sent seeds to people in Kansas City yesterday and Monsanto could sue me because I sent seeds from my yard and they could say that those seeds somehow originally came from plants that they produced. So I wasn't authorized to touch those seeds. Because basically if you have seeds now, you're supposed to destroy them because the only legal seeds come from
Yeah,
Monsanto.
Johnny.
I'm gonna report you.
Huh?
I'm gonna report you.
Okay.
Yeah.
Make my life easy. Except I can't eat in jail. Just remember, they won't give me food that I need. That's not man, would be
If I have $1,020 bills and I stick them in a pocket that has a hole in it, I walk out of here
right.
doing a trail of $20. Whose fault is that? Is that his because he picked them up?
Technically, you're not supposed to pick up money that come forward, but yeah, it's.
Yeah, it's his,
Yeah.
because the people that did that with that semi that overturned, that they found all of them from cameras, from video footage and charged all of them with taking money from that scene of that crime.
Yeah, but if I take off, disappear, and you never see me again, what's he supposed to
I think
do?
it's they make.
He's supposed to take them to the police. He's supposed to take it to the police
And
and,
then it sits for a while. and
well, for
nobody
30
claims-
days and then he can have it.
Yeah.
But you asked what he's supposed to do, I'm telling you.
There's no way to make-
But
There's
the
no way
thing
to
is,
go through all your seeds and make a reasonable attempt to bring it back. Like you can't do that with seeds. So there's
No.
there's no reasonable attempt on there. It's just should be just
It is crazy.
so every day I should go up to my farm
exactly.
and comb through the dirt to see what seeds are there.
You just sell it to Monsanto and they'll take care of it.
That's not reasonable.
It's not at all. Polymorphism. Okay, so like I said, I like transformers because they morph, right? To me, they morph from one body type to another. So they're a really good example of polymorphism. But that's not really what polymorphism is in object-oriented programming. Sort of. We'll get to it. So poly means either combining form or many, much, which is true for our instance of polymorphism in both cases. And then morph means,
Change.
yeah, it's like each of several variant forms of an animal or plant. So kind of an unusual definition because I would say to change. So polymorphism is to take many forms. That's really what we have here, many forms. And if I look at a caterpillar that's morphing into a butterfly, that's accurate. There are many forms going on there. So how does that matter to our Transformers project? Well, again, our Transformers base class implements this abstract method, transform. It says, I don't know how an Autobot transforms, but I know they've got to. And I don't know how a Decepticon transforms, but I know they've got to. So I'm going to implement this as an abstract method, meaning every method or every class that inherits from me must implement the transform method in their own way. So that's an example of polymorphism. The transform method works one way for another Cybertronian. It works another way for a Decepticon. It works another way for an Autobot. It's still always the transform method. We can call that same method when we want to transform, but the code, how it actually works, is going to be different depending on the class, right? So many forms. That transform method can take many forms. Now, when I look down another layer, maybe my Dinobot has a very specific transform method also. Well, it can implement its own transform method and override that at that level too. Or it could use its parent's implementation, either one. So we can work there. Now, our Autobot over here overrides the attack method. That one was marked a virtual, saying it can be overridden, but none of the others did. They were all like, nah, that attack method works fine for me. I'll just keep it the way it is. So they have that option. So polymorphism, we're allowing multiple implementations of the same behavior, many ways to transform, many ways to walk, many ways to fly, really, when we're looking at transformers. So the appropriate implementation should be used based on the situation. What's the situation? Well, what class we're in. So if we're in an Autobot class, we should use the transform method in the Autobot class. Object-oriented programming overall, a class is a noun. It's an object. So anytime I think of a class, I'm going to be thinking of a person, place, or thing. Would you agree? Can you think of any time it's not a noun? Usually people have something. Now, whenever we're looking at inheritance, a child of a transformer, like an Autobot, is a transformer. Is that true? He's still a transformer, right? He's just an Autobot type of transformer. So in the same way that if my parents' last name was Smith, I would also be a Smith. A child of a transformer is also a transformer. Now, whenever we instantiate a class, we create an instance of that class. So Bumblebee would be an instance of an Autobot. Bumblebee is a transformer. Bumblebee is an Autobot. Right? So that's an is-a relationship. It's really important. Now the data, the class fields and properties that are encapsulated by the class have a has-a relationship. So a transformer has a name. Whenever we're looking at a class, we usually have a is-a relationship with our parent. So an Autobot is a type of transformer. Now when we're looking at data, we're looking at a has-a relationship. The composition of that is the name is part of the transformer. Now these seem really cryptic and like, yeah, duh, I'm good at the English, but there will be a lot of questions like this on the MTA exam. And it's kind of weird because as long as you don't get carried away and try to make it any harder than it is, it really is that easy. But sometimes when you look at the questions, you'll be like, that can't be that easy. That's not what they want. But that is what they want. But a child class is a whatever its parent class is, and whatever data we're looking at is a part of or has a relationship. Okay, so here we see sort of that constructor. It's PowerPoint, so it's not perfect. We're going to make one perfect in Visual Studio. And then we have a line of code that's instantiated an instance of an Autobot. So first we have our class name, followed by the instance name, followed by the equal sign with the new class name again, and then all of our parameters. Now in this example, we're listing our base class parameters first, and then our derived class parameters. And we don't have to do it in that order. We can do it however we want. That's just what they did in this particular example. Now, whenever we are working with our class to use our getters, our properties that get data, we specify our instance name followed by the property name on the right side of the equal sign. So if C# sees access of a property on the right hand of the equal sign, it uses the getter. So when I ask for name, it's going to go to that property name and run the getter. Now, if I see that property on the other side of the equal sign, on the left-hand side of the equal sign, then C# is going to run the setter. And it's going to take whatever is on the other side of the equal sign and pass it down as the value. So finally, when we're working with object-oriented programming, if you guys have seen, we just only need to add a few keywords to what we've already been doing. So the code is really simple. It's not a big deal. The terms are harsh. The concepts can be a little bit rough to totally understand. So the abstraction, we're getting down to the most basic pieces, trying to hide those from others. Encapsulation is hiding the details within our class. Inheritance is using the basic details and adding more. And then polymorphism is being able to use the same method for multiple items or multiple objects. Okay, that one's crazy. We have a lot in our textbook. You should be looking at chapter 6. I'm going to go back to this and then I'll go find it to be sure. And this one might be one that is in those videos. I just wanted to look at it really quick. Let me get it in the right place for you. I was really hoping Neil would be here for his 120 class so we could fix that problem. Okay, I was telling you guys last week that we're going to be trying to work towards this 3-layer implementation for our applications. And here's a picture of it. So usually we're going to have some sort of data component, and we'll get into that right after midterm, our database access. So our database is going to be back over here, and we're going to have a data access layer that does all that communicating with the database. Then we would like that data access layer to communicate with a business layer. This business layer is usually our class code, like our transformer classes, our Dinobot classes. This data access could be finding out information about the different transformers, like what their weapon type is and things like that. And then the presentation layer is the user's front end, what they're seeing. So we like to keep these separate because we can identify resource conflicts or resource problems. If my database server is running really slow and getting hit really hard with I/O, I can upgrade that server, or I can update my Amazon Web Server plan, something to get something that has a little bit more resources. In the same way, if it seems to be my server running my business components is having a hard time, I could throw more resources just at that section. And then if it's the user area, I can make sure the desktops are up to speed. So instead of just throwing resources and resources at it, at our system, we can actually identify which layer is causing problems or is tight on resources and allocate resources for it. So that's one reason we want to keep everything in these layers or component based. So our 3-layer model is what they call it. We have the presentation layer that the user sees, the business logic layer that we are working with a lot, and the data access layer that we and the database administrator might be working with a lot. And finally, our data source that's being accessed there. Now, I have a friend who has been in development for a really long time. Anyways, the last time we mentioned this to each other, which was a while ago, she said, oh, what are you talking about? It's like a 5-layer model now. And they asked this morning, what are those other 2 layers? I don't know, I'll ask her and find out. But she was like, I said something about, well, we're trying to get them aware of the 3-layer model. And she said, oh, well, that's great. But you know, there's like 5 layers. I'm smarty. And I'm not sure what they are. Probably, I'm not going to even guess. I'll ask her, what were you talking about, women? And then our 3-layer app that we're going to work towards, we're starting now. We have a class, at least in the videos, you saw where there's a person class and then a student class that inherits from that. This student class may not match that one exactly, but we start out our 3-layer app with our class code. Now, this student class might match exactly what our database table is going to be. And we can give us a good starting point. So whenever we're working with these component-based models, we're just trying to keep track of what layer something belongs at to make sure the code isn't in the wrong place. Whenever we compile a Visual Studio project or solution, we've seen that if we go into the bin debug folder, you can find your executable for your Visual Studio code. So if you haven't found that, we want to go find that. But I could copy that exe file to the desktop or whatever and then run my application just by using that exe file. Well, with our component-based development today, we're going to start looking at a class library instead of a forms-based application. And in a class library, we're going to be generating a DLL, a dynamic link library that we can use then to serve as an API for our code. We could give this DLL to other people that could implement it in their code, or maybe just other groups within our company. But that DLL is also going to be saved in that bin debug folder. So that's where we're going to go find that to add that DLL to another project. So I don't want to create a class that has a student or a person. Those are all in those videos. And I don't want to do animals, because there's videos out there for animals. What kind of class would you guys like to create today, really, really quick, that would get you prepared to create your park class in derived parks?
Building.
A building? Building is okay. Building. Everybody likes that. That's a really good one. So if we had a building class, what would you see as being our derived classes from that? I guess what could we could have like house. What would be another?
Garage.
Garage would be a building. Is that a good one for our experiment here? I'd like something that's a lot different than a house, I think.
Office building.
Apartment. Let's do apartment building. Okay, so we'll have these as our classes. I think that's great. What kind of data do we want to keep for a base building class? What is every one of these buildings going to have?
Dimensions.
A what?
Dimensions. Like how big they are in each direction.
Okay. What else? Rooms. Would we have an address? What else?
What it was made of, I guess construction material.
What else?
Style.
Style. What I'm looking for, purpose would be good. What I'm looking for are some parameters that we could use that have different data types. So all of these are really good, but we only want a few because we're gonna have to type them all. And we wanna make sure that they have as many different data types as we can explore so I would really like to have one that's a date time. Have you ever done any data types that were date times? That's why we should do one.
Date constructed
That would work. Let's do that.
for construction date.
And I'm sure that in the construction industry, there's some sort of date that's when it actually got done, but I don't know what that is. But that would work. I like that. What about number of stories? So we could just use an integer. So for our composition, we could use a char data type and have like a code table or something that we use for that. So let's say we're going to keep that one. So let's keep our address, our composition, date constructed, and number of stories, because we just want a few parameters, because like I said, we're going to have to type all these. All right, so then what about a house? What would we need to add data-wise for a house that would be different than other types of buildings?
Number of bedrooms.
Bedrooms and bathrooms.
Do what?
Bedrooms and bathrooms, like.
Yeah. I think that's probably enough. What about an apartment building?
Apartment number.
Do what?
Apartment number.
Well, that would just be for one apartment. So we could do how many? Like how many apartments?
Would we be able to have like a derived apartment class from that?
A what?
Like a derived class for like a specific, like a single apartment?
If you wanted to, Yeah, because you might have one-bedroom apartments, two-bedroom apartments, different things like that you'd want to have derived off of that, for sure. Let's see, we've got a number of stories. How about like, how's that elevator? I could,
Boolean.
we'll put a Boolean in there.
And you can put number of elevators.
But I want it to be a Boolean.
Oh, okay.
So we'll just say has an elevator. So we can add tons and tons of stuff, but let's stop there. And let's see if we can create something really quick. So I'm gonna open Visual Studio. And I'm gonna create a new project. And for this new project, scroll through your templates. And we want to find the class library and make sure to use the .NET standard. If you use the .NET framework, it will work, but your DLLs will be in different places from the rest of us, and it'll just be a little bit different. Now, before I do that, I want to add this to my source control. So I'm going to cancel, because I should have made sure I was connected to TFS first, and I didn't. So I'm going to go to Team Explorer, click on my connection. Looks like I'm connected. Okay, it's letting me see stuff. So now, again, I'm going to do File, New Project, and I'm going to choose class library.NET Standard, And I'm going to name our class Building App. Now we want this name for our solution to be related to our class because it's going to hold our class library, but we don't want it to be the same. So make sure that your solution name is not the same as your class name.
That's cute. I'm getting no servers now.
For,
Connect. On project.
oh, okay, hang on, we'll look. All right. CIS2. Do the CIS team first.
Oh, yeah.
Did you see that?
Wrong one. And daughter last night.
Just like, you should be able to delete it.
Shouldn't be a doctor.
Huh?
Shouldn't be a daughter.
Oh, what you do, delete all that. So CIS2, that what you see that.
Oh, without me. Here we go.
If you click on the username, you'll have access to both of them.
Yeah.
Is everybody finding the TFS stuff okay?
I am really fine on my end.
You okay?
Yeah, I hit control, that's, yeah, everything's
Got it. All right. I think that's working. So whenever we open this class library, it starts out with this class 1. Now, can I just rename this over here, or do I need to rename this class1.cs file in my Solution Explorer? If I just rename it here, it will not change the file name, and they do need to match. So I'll have to do them both. So if I did the file name, Visual Studio would do the class name for me.
Are we supposed to be doing .NET framework?
No.
Standard.
Mhm.
stuff?
So I want to document this class. I'm going to press enter on my class and then do the 3 slashes to get that XML comment. And my summary is going to say, this class defines a building. And then I'm going to go ahead and put my name and the date. And if you want to make it fancier, that's great. Now, in my building class, I want to add all those things. But I remember back in C#1, we were able to show that class diagram. Remember they had that really handy-dandy utility down at the bottom where we could develop our class really fast? Can we find that? I know then we right-clicked on our .cs file, and we chose Show on Class Diagram or something, and I don't see that option. So I did some research this morning. Those people had to type in their classes all by hand because we couldn't find it. And I think that I found it.
I can find it, usually it just takes me 5 minutes, because I like to look at it on my first.
So how do you find it?
I can never remember.
I've got the
I don't
Google
think
thing.
it eventually shows up.
Class diagram. Well, I can show you how I got it this morning, but that's a dumb way. I might have to show you that way. Oh, I know. Okay, so right click on your project and choose add new item. Now I remember, now I remember. When you get to add new item, click on general here for your category, and you should see class diagram there in that list. I'm going to leave it named class diagram 1.cd because that's okay.
Where was the add new item?
If you right click on the project, choose add new item.
You can't find the class diagram option anymore.
It's like, I don't know, they installed it weird or something. Now, notice it says that in the class diagram, you can visualize items by dragging items from the class view. So take your building.cs file and drop it on this class diagram. Did you find it? You should see the building on that class diagram. Looks good. Now, down at the bottom, we have that utility where we can type everything in really quickly.
I can't find the class diagram. You should have everything shown.
It should show up when we right click on it. Now I'm just trying to see it. That's all we want. Perfect. Okay, so now down at the bottom, we have all of these class details that we can use to type everything in really quickly. Now we're sort of cheating, but not really, because we have to create these classes really fast. So I'm going to start with fields. So come down here to where it says add fields. And the first field that we want is address. So I'm going to type in address. And then if I tab, I can say that it is a string. And I want it to be private. And I could even add a summary here if I wanted to. That would be like help information. Okay, so there's our address. And I can't zoom in at all. Now the next field that we need is composition. Nope. Composition. So I think for this one, we're going to make it a char, because we're going to say we're going to have a list of composition types that we will accept. After composition, date constructed. And I'm going to make this a date time. And then the last thing we had was number of stories. We'll make that an integer. Now we should have some nice, good variety of data types there. Now, can we go back? If we look at our class now and extend it, we should see that we have those data fields now in our class. What about if we look at our class code? There they are. Let's put them in there for us. All right. So now I'm going to go back to my class diagram and do properties. We're going to have address is a string. Composition is a char. Date constructed is a date time. And the number of stories is an int. Now you should see from looking at this class diagram, the top half of the screen, that it's giving us those properties. It's setting them all up as we type them in. So if I switch it back again to my .cs file, I should see some sub sort of getters and setters. We might decide that those weren't very good, but we've got something. Now we need methods. What kind of actions should we have for a building? This is a hard one. We need to think of a method that we could use that would be virtual, that will let people override, but they don't have to. And then we need to think of a method to implement that's abstract, that we're going to make all of the child classes override. So how about for virtual, could we use like mowing frequency? And then we could say you can implement that, but you don't have to. Or can you think of something better? And then trying to think of what a building thing is that you have to do that we can't get away from.
80 electricity.
But how would we implement that differently in different methods? We could do it, be a lot more in some buildings than in others.
Trash pickup day.
Yeah, but you pick up the trash the same in an apartment and a house. I don't need a different method.
Is that a property tax?
Huh?
Property tax?
Property tax would be different, but how could we, there's something about it if we could use something that would be.
We could use like some kind of equation inside of the method to determine what the property tax would be for a building of that type.
That would be good, like property tax percent. Let's do that. Property tax percent or something like that. And then that way we can implement those. So we're going to have a virtual method. So let's see how we put that in our methods here. The virtual method, mowing frequency. So for our type, our mowing frequency, what do you want to return? Like a string that says we mow every 2 weeks, or do you want it to be, I think a string probably. And then in our modifier, can we say public abstract? Nope. So we're going to have to add that manually.
Can abstract be used?
Yeah. It should be right after public, but I don't think it'll let us. Now our other one, property tax percent. We're going to go ahead and return a string out of that one too, so we can just send a message back, because otherwise we'll be in trouble. Now that should have a lot of our class already created. Now, can we add a method that's our constructor? Or is it going to mess that up? I'll leave it there. I don't think it's going to work very well. Now I want to look at our code and see what we've got. Got some errors. Okay, so first of all, let's get rid of the system dot on our date time. We don't need that. Let's say it's date time.
What was the last thing you did after, what was the thing you did after property tax percent?
I put in a method called building just to see if it would work as a constructor, thinking that we would probably have to change it a lot.
Called it string,
Building. I just called it building.
it's a string.
Yeah. So this is the constructor it put in there for me. I'm going to just cut that because I want to move it down after all of these properties. And we'll fix it here in a minute, but I want to fix these properties first. So I just moved that out of the way. Now, can you think of a really fast way to fix these properties? Or should we just delete them all and use that utility that's available here? Let's do it. I'm going to delete them all. They all look pretty messed up. So I'm going to start here, public string address, and I'm going to delete all of the stuff that it put in here for these properties. Sometimes as we generate code, we can make things worse. Okay, so I'm going to delete all of my properties. Are you with me? I want this to be easy, and it's not going to be. Now, how can I make those properties really easy? Well, remember, I can select all of these private data fields, and I can use the light bulb, the quick actions, to say that I want to generate and encapsulate fields, but still use field. And I like those much better.
My code doesn't look anything like yours.
Why?
I don't even,
Apparently you can use that for constructor too.
hmm?
The-
Yeah, you can generate a
you had
constructor
some-
too.
Because you had some reason, is that the reason there? The like small thing.
Uh-huh. Yeah, so these lambda expressions are okay. Now, if I used the quick actions and said I wanted to encapsulate fields and use properties, then I wouldn't have any private data fields in my class anymore. Everything in my class would be public, and that would be okay if that's what I wanted, but we like to have our private data fields. Okay, so let's make sure all of this looks good. I'm going to add a # region to say here are our private data fields, our instance variables. And then at the end, I'm going to put the end region. And I'm going to have our public properties and our public properties. And then we have this terrible constructor. I hate it. I'm going to delete it. But I'm not going to create one manually. I'm going to select all of my data fields again and use that quick actions to generate a constructor. And again, I'm going to move it. Sorry, I keep moving stuff. But I want it to be after our properties. I'll go ahead and do the # region. Our constructors are here. Now for this constructor, we're requiring all the parameters, all of our data fields. I'm going to document this constructor. I'm going to press enter and then do the 3 slashes to generate the XML comments. My summary is going to say fully populated building constructor. Now, because we're using these XML comments, when we generate this as a DLL and we include it in another project, we're going to see these comments. We're going to be able to use those.
And how did you make that?
3 slashes.
3 slashes.
And it'll automatically generate all the rest of it for you. So when you do the 3 slashes in that XML comments, it generates information about all of your parameters. So that kind of means you need to do the comments last, which is kind of against our way of doing things, where we kind of like to document first as we do it. But it won't grab all that information until that information is there. Let's do one more constructor. This one will be public building with no arguments. And let's set all of our data values to some sort of default value. Default address. We'll make it U for unknown. Now, to specify a date in our code, we say that we have a new date time instance, and then we do month, day, year. So the class this morning, we thought we should use like a special date so that if we have any buildings out in our database that were created this way, we could search, we could do an SQL query to find all of the ones that have this given date. So I think we ended up doing like 01/01/1901 or something like that. I don't know if that would work very good for a building though, because we could actually have a building that was built that date. So how could we come up with a date that would be like not a date, but yet a date?
For a company, then you probably do it the day before the company was founded, so we can use.
But this is going to be in all of our buildings if it wasn't given a date when we created it. It's a date.
Out of the year, it's a 10
Can I have that be a date?
Whatever the highest year is that you put in.
I don't know what that is.
You can just do like MMTV, blah, 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 blah.
No, it's a date. It has to be a valid date.
01, when we were
I'm leaving it 9001. If it crashes on you, you know.
February 31st.
Huh?
February 31st.
It's not a valid date, so it won't let you. We'll see if it'll take 9001. There's a chance it might.
We'll let you go into 0001 for the year, maybe. I'm pretty sure that would.
Yeah, we might not. We'll try that. Be thinking about it. Okay, let's fix our next two. For our mowing frequency, we're going to say this one was supposed to be virtual. So I want to add that virtual keyword. And I want to return mow every 2 weeks. That'll be our default. Huh? Now our property tax percent is a little bit different because we said this is going to be an abstract method. And here's how I code those. Now, this should be right. I've got that abstract keyword. Why is it not taking it? What kind of message are you getting?
Well, you got it. Oh, so what your system
It's in a non-abstract class.
So we have to make our class abstract to be able to use this abstract method. And that's right? Because if we have an abstract method, our class is obviously abstract. We don't know enough to create an instance because we have a method in it that we said we don't know enough about. So obviously we don't know enough about the whole class. So I'm going to mark this class abstract. And we should be ready to save that. Make sure to check it in so that you have it. And what I'll do is I'm going to create our derived class, just one of them. Let's see, I'll do our house so that you can see that constructor. Because on Wednesday, when you guys come in, your base class and your derived classes for your sports team are going to be due. So remember, we're still going to have another week to work on those and solidify them and stuff. So as long as you have something by Wednesday, you'll be good.
When you're done with class, can you actually come look? I already have them all.
Sure,
built.
sure.
I was driving yesterday. I'm sitting in the back of a car.
Oh.
Didn't make you sick?
No, I'm sitting on a highway for 10 hours.
You can hit him in Discord tonight.
Yeah.
Hit him up. Is it okay?
I did something, no. That's all it did. And I don't have the third one up there. It didn't click
The stuff. Well, I don't think that our class generator thing was time saving to you. I don't know. I thought it was going to just whip it out, but I don't know. I think that we almost did just as good using the quick tools, yeah, with our data elements. I think probably maybe give us a little more control. At least we found it. So I'll post this and the other one to the Discord. So just keep watching. It'll be that separate C# one with the little blue icon sort of that we
Seems like
create.
it's more for tweaking some classes visually than if it's for making them like the class diagram.
Right. It's so you can see the relationships between your classes and things like that. So now the thing is, for this one, we got it set up as a DLL. So we need to generate that DLL. So if yours is having trouble, that's okay. Just follow along with me. If I try to run this right now, it tells me I can't. It's a class library. It can't be executed. But I still need to compile it so I can use the build menu. So on your build menu, I'm going to choose build building app. Now down at the bottom, I should see build succeeded, so I know it's done. And now I need to go look at my project folder. So I'm going to right click on my solution and open folder in File Explorer. It's my building app, my bin, debug, net standard 2.0. And finally, here's my building app.dll. Now I'm going to use this, so I know we're going to run right up to the end. Hang with me, it's important. The DLL is what I'm going to need to include in my next class library that's going to inherit from this one, so that it knows what a building class looks like. If I include it directly from this project, and then I come in and change this project, I'm going to affect that other app. I can't do that. I need to copy this DLL into some sort of folder, some sort of managed DLL library. So let's create one. Go to your H drive. And on your H drive in your documents folder, create a new folder. Yes? You don't want to do the other build.
I'm going to build menu, building app.
Right, the other build. Go down further. Thank you, sir, because we're going to run out of time.
Build solution. That's all you. Open that field.
Now, I created my DLL library. I'm going to copy this DLL into it.
Something you're not paying.
Oh, wait, it's on our one, right?
That's weird.
Yeah, and I think if you put it on your OneDrive, then you'll be able to get to it from home. I'm going to copy it now.
No.
If I were doing this at work, realize there would only be like a few people in the company that had access to update the CLL library. I would give them my DLL and I would be, this needs to be put into the library, please. And I might have forms and paperwork that I need to fill out to have that happen because of this change, this project, whatever. And then that person with that right level of authority is going to update that DLL in that library. I'm not just going to be randomly hairy-carry changing DLLs that 1,000 applications use.
No, I don't know why you're getting an error on the first line of code.
So you guys just watch me, please, and don't worry about it because we don't have time right now. So I need you to watch me or you're not going to know what to do. And then we can figure out what your problem is after a minute. But right now we're going to be out of time. So we copied that DLL to our library. Now I'm going to create a new project. And again, all of this is on those videos. So I don't feel super bad about rushing, but I like to do this part together. When I create this new project, I'm going to say that it's a class library. And this one is going to be, what did we make that? A home? A house. And I'm just going to pop that into the same everything. And all I want to do is get to our class statement. So now, my house class, I want to inherit from my building class. Building cannot be found. So I need to add a dependency. In your Solution Explorer, right-click on Dependencies and choose Add Reference. Now, this utility shows mine already. Yours is sitting up here. It's going to show you all sorts of different references you can add to different things. If I look at this COM reference, I'll see all sorts of Windows utilities I could add to my project. But we want to browse. So I want to click Browse, and then I want to click the Browse button. And I want to go to that DLL library that I just created and find my DLL. Open. And now I should see it sitting right here in my references. And click OK. Still giving me an error. If I look at my dependencies now, we should see it. Building app. So that's what I have to add in my using. Using building app. And then that error should go away. Whoa, and it's 3:20. Now the reason we have an error on the house is because we need to implement our abstract method, property tax %. So we've got everything right now on our header stuff. So Wednesday morning, your due time is 8 o'clock. And I like to leave it like that. I don't want you worrying about it up until you come into class. But by Wednesday morning, just get your team and 2 derived classes turned in. You can have some issues because there is no way to test them yet. So having issues is our, because we haven't tested them. Are you going to show them?
Yes, I was going to show you.
All right. Okay. We're done. Thanks, you guys. Get out of
I gotta
here.
go study calculus. I got 3.
Oh,
So they're working.
Uh-huh.
This is my. Let's go to the main one first. So I'm just following your videos. I have the 3 variables for right now in there, but
Nice.
everything's returning and everything
Great.
is going. Then I have 2. I have 1 for baseball. I have 1 for football. So I just have 2 variables set going right now, and I have stuff inheriting from the base, which is exactly I think what we
Awesome.
wanted to do.
Yes.
And I did the same thing for the football one. So we're just inheriting from that. And I think I might add some more variables later on for whatever we need to do.
Great. That's
I
awesome.
think this is cool, because you can actually go in here and add more variables when you're doing these classes. It's like management-wise, it's so much better.
It's such a hard decision. Every semester we do this. I think, we shouldn't let's do all this.
I like the dynamic link library.
It's really important for us to
Well, I
know
do
how
want to
to
learn
do it.
more about DLLs, because when I do
Yeah.
do you know what VST64 is? Like virtual instruments, they use DLLs like crazy. Like, so when you're trying to load an instrument, they're using a dynamic link library. I'm like, what in the heck is a DLL when you have to drag it into your VST plugin folder? So now I'm getting a better idea of what they're doing. That's like,
So it's probably just for this specific instrument or
yes,
something
exactly.
that you need to fix.
I
I'll
mean,
post it to Discord.
So I'll post tonight to you this, Riley.
Awesome.
But the weird thing was, it created a DLL.
Did it?
Yeah,
It's just not doing it right.
I mean, I don't know, I'm gonna compare yours to mine, but
You guys,
it didn't create
I tried both of these.
the,
and saying it's not
mainline.
I'm not calling her. What's
So it
yours?
doesn't seem to think that.
Oh, you're done. Okay.
It wasn't the right.
I'm done.
It's really follow the videos that she has on there. It makes it extremely good. Watch the first 2. That will make you start it.
Well, I finished the first one.
Okay.
But what I did,
And make sure you load the DLL class library and then just.
Where I told you to.
Got it
so
all.
I spent 45 minutes and I said, that's it. But, yeah, I can grab this and log out. Well, let's do it. No, I didn't log out.
It's just that I get the right one.
Restart.
Yeah, it should.
That way I know it's disconnected.
I have a calc test in Thursday
They
again.
would, like, leave this
I have a
all
calculus test
continue.
Thursday.
Not really.
So, and I missed
Okay, then I shall-
last Thursday because I was driving to Michigan.
No.
So I got so much content now to go over for this day.
Sometimes people have been able to
Off
clean
one
stuff,
day.
it's just not very big. I think it just causes you so much
And
trouble.
then I need to.
Where you going?
Well, I know how.
Oh, that sounds like fun.
What is it? Building.
Nice.
Bill, class library 165.
And then you can- So that should do it.
And the rest of the stuff was just, all you were doing is just making a folder for this stuff.
Put the DLL in,
Yeah.
and then when you create your derived class, you have to add that dependency
Yeah.
to that other one.
It seems fairly simple.
Yeah, it's not
It's kind
bad.
of like how Unity gets stuff, and all it is just like,
Yeah, it should be just the same.
you're gonna like. check
Since
this
Unity's
in.
all C#. Do what?
I'm just gonna check this in and then leave.
That looks good. Yeah, it's just if you don't pick that type of project, it gets all upset with you. Yeah, I know, it happens all the time. I'm sure I think there's one that just is really close.
They're not really like very. They have these icons. They seem like they should be good, but we're just. I don't know what it is about the way that you pick one. It's like.
There's just a lot of
yeah, there's a
them.
lot, and they look kind of similar, and then.
Yeah.
sometimes it'll be like.
Kind of a pain.
Or you'll think that you think that it starts with like all of them and it gets narrow, whereas you like do the thing. No, it starts very narrow.
Yeah, you have to get